that specific question. So while we're going through this question, yeah, the one thing you're going to notice is that whatever we're going to do, it will make sense, yes, but then the issue will always be how is it that you're going to remember to do those things when you're on your own, you see. And the only way you will be able to remember to do certain things on your own is if you have gone through them on your own and have maybe checked the memo and all that, because you don't want to underestimate how powerful it is or how powerful knowledge is when it is something that you have somewhat like learned on your own. It's just weird. But anyways, let's just see. So it says here 10 squared x plus 2 10x minus 3 over this whole thing. They basically want us to simplify this expression. See, they want us to simplify. So if we're going to simplify this expression, the one thing we need to keep in mind is, as we mentioned already, the top part, we don't necessarily want to jump straight into assuming that we should change to sine over cos, because just the format, it's not very conducive to change. The issue is, if you're going to change something, right, always ask yourself, is it going to help you? If it is not going to help you, or if it is going to make this actually a bit more complicated than it looks, then you might as well not do it, because here you're going to have a fraction on top, another fraction, and then this division line, it's a fraction on its own. Down here also, eventually you're going to have a fraction, but down here it kind of looks like it's going to make sense to change. But then let's see, at the top we said what we should be seeing here is a quadratic equation. Now with this quadratic equation, the one thing we can already see is we would need to factorize, you see. So what you can look at is, think of something like where you have x squared plus 2x minus 3. That's hypothetically speaking what you could be seeing here, you see. Because factorizing this, you know that you need factors of 3 that give you a 2, of which those factors are 3 and 1, of which for you to get a plus 2, you would need to say a plus 3 minus a 1. You see, so you know that a positive 3 and a negative 1 are the factors that can, give you a positive 2 there. So this factorized would just be 2 brackets, where the first bracket is a plus 3, the other bracket is a minus 1. So you knowing this, you can just apply it for the 10 squared x and everything. Meaning what you have at the top here, you can automatically just put 2 brackets. Instead of putting x now, you can just put 10x, and then here plus 3, and then 10x, and then minus 1. At the bottom, without us like rushing into anything, you may be wondering, okay, but what is the reason behind us factorizing the top? So since we factorize the top, the good news with factorizing is it allows you to have something that is easier to work with, you see. Like, it is not, it's common knowledge that anything that is factorized is easier to work with. You can easily cancel stuff at the bottom and stuff like that. So down here, it looks like this we cannot do anything with it, so we might as well leave it for now. However, here you can see that as long as 2 things are being multiplied together, it means that it's one thing. So this one thing here, it looks as though we can change this 10 to a fraction. So we're going to have here sine x being multiplied by sine x over cos x. So as long as this has become a fraction, you might as well make this a fraction as well, and then this a fraction as well. It's just going to help you to work with it better. So the bottom part, we can see it's more like the main event right now. It's looking a bit it's looking a bit shaky. So just actually just taking a snapshot of this, just looking at it in my head, it does not look like if we expand this, it's going to make our life easier. It looks like if we multiply these two and have sine squared over cos x, it doesn't look like it's going to make life easier. So what I'm already reverting back to is, if we're just looking at what we have originally, you see, and don't worry about like rewriting anything that is on the screen. I'm going to save this as a PDF file, and I'll just send it to you so that you have everything that would have like written out. So you saw what we just did right now. It's something that we wrote out because it was an idea. But then, writing it out after, having to have gone through different examples, the way it was coming out, it doesn't look like it was going to be broken down nicely. Also compared to how the top is. So normally when you factorize the top, you would want to think to yourself, how can the bottom end up having something that might look like one of these? So fortunately, at the bottom, you see there's a 3 somewhere, and then there's a 10x somewhere. So without even overthinking it, you can already think to yourself, okay, wait, there's a plus in the middle here, so it's 2 separate terms. And then these 2 separate terms, they both have sine x in them. And you can imagine this is not something we like saw immediately. No, it only came about when we had done what we thought to do. But now, having to have done what we wanted to do, it didn't look like it was going to work out. And it didn't look like it was going to work out based on other examples that, you know, I've maybe like gone through over time. You see, it's a lot of pattern recognition when it comes to math, of which it's not something that you can say is limited to only a specific group of people. You know, everyone has the same brain. I mean, there are different brains, yes, but they all work the same, one or the other. So here we can take out a sine x as a common factor. So if you take out sine x here, you're going to be left with 3 here. Here you're going to be left with 10x, of which this is actually what makes this question a bit simpler than how it looks in the beginning. Because just by looking at this, we can see that, okay, wait, this is factorized, and then the top is factorized. And we said it's much easier to work with expressions that have been factorized, because an expression that's factorized, it's easy to work with. Like now, we have this bracket at the top here where we can cancel this one, because it's the same bracket. Whether it's the 3 first or the 10x first, it doesn't matter, because there's a plus in the middle there, you see. So these automatically go away. And then whether we like it or not, there's 10x minus 1 here over sine x. So this is the way it looks. I doubt this can be a bit simpler, but we might as well try. So let's maybe think of this as a mini checkpoint to say, if it doesn't get any easier, we'll just revert back to this as the simplest form. But let's just see if this can get simpler. So attempting to make this simpler, you don't want to jump into doing things that will make it go bigger. You don't want to do things that will expand your expression too much. So what I'm thinking, when I say what I'm saying now, I'm trying to refer to how most of the time people want to, you know, change the 1 to like sine squared x and cos squared x. It's something that most people like to do, but it's not usually a good idea. You're better off leaving the 1 the way it is. But then for the 10, we could maybe think to ourselves, let's maybe change that to like sine x over cos x. And then because we have a fraction here, we might as well change this to a fraction as well. Let's maybe put it as 1 over 1. And then, I mean, the top part, it looks like that's the only place where something can happen. So for the top, let's see, we can have an LCD here. The lowest common denominator is cos x. So there's cos x here, cos x there. And then let's see what else. Let's see. At the top, we will have there sine x minus cos x, the whole thing over cos x, right? And then that is over sine x. So unfortunately, yeah, it doesn't look like it's going anywhere. But then the top part, since we're dividing it by sine x, the one thing that we could rewrite it as is maybe sine x minus cos x at the top. Hold on, cos x over cos x. This is technically being divided by sine x, of which we can put this over 1, so that at least it's a fraction and a fraction. And then since there's a division symbol here, we can change it to a multiplication symbol and flip this over. And then here we have sine x minus cos x over cos x. And then while we're carrying on here, we can clearly see, yeah, it doesn't look like it's any simpler than how it was in the beginning. It looks as though the one that had the 10 is, it's more or less on the same level of, you know, what's simple or whatever. But here we can see the top multiplied by 1, you are just going to have this. The bottom multiplied by the sine x, you're just going to have this. Of which from here, you can safely say there's no ways you can go anywhere from here. So this is as simple as it gets. I would say, normally if you leave something with a 10, yeah, this is where, you know, the memo would play a better role in terms of us seeing, okay, which version is is better. But normally something with a 10, you may want to just take it a bit further. Of which, if you look at these, I mean, they are both simple in their own right. You see, so I think depending on the mark allocation, if this is like a 3-mark question, this is virtually good enough. If it's a bit more, maybe going through until ending up with this might work, but yeah, it's really not usually a big deal. So this is fine here as the final answer. So does that make sense?
Yes.
Okay, perfecto. Let me just stop this one and then we can start with the next one. So